Let's go ahead and begin. This way we have ample time to cover some of your questions towards the end of the presentation. First off, thank you everyone for joining this morning and for those in Europe, this evening's presentation regarding leveraging the IoT Cloud with some of the leading cloud platforms such as AWS and Azure. Some brief things I want to highlight before we start. So first off, we are recording this session, and this will be made available to you later via our YouTube channel. And then please feel free to use the chat window to share your questions. We will plan to address those during the latter half. I want to begin by introducing our speakers today. First, we have Adrian Larabat. He's our senior software architect. He's been with Witekio for almost 8 years. He leads many of our customer system workshops, and he also helps to define their system software architectures. So happy to have Adrian here to join and be part of the discussion.
Hi, everyone. Thank you.
And we also have Fernando. He joined Witekio recently, but he's been a cloud architect for some time now. He has a lot of tutorials and how-to guides that he shares regularly on his social media. So feel free to follow him on LinkedIn or Twitter. And then myself, this is Sid Nagandran. I've been with the company for about 2 years now. And I work in business development. I support late-stage startups as well as Fortune 500 companies and helping them with their embedded computing needs, mainly with embedded software. And our goal is to help customers accelerate their time to market, as well as help them to differentiate their product. A little background with Witekio. We've been around for almost 2 decades. We have offices in Europe, as well as in Seattle. That's where the speakers today were based out of. And between our Europe and US location, we have close to 140 engineers, so really able to scale and support customers in different regions. And being in consulting, we actually see over 100 projects a year. So there's really nothing we haven't seen before. A quick overview on the software stack. So this is important because today we're going to be covering a lot of the cloud integration piece for your IoT device. But something to keep in mind when you're building a embedded device, important to have an understanding of the full stack. So that starts with the kernel, then the middleware, and then the application layer. And you can either have the skills in-house or important to work with the right software partner that has experience with the different types of hardware that are out there, and that can help you navigate through just the multitude of choices. So that's where Witekio is here at your service. We are a consulting partner for, like I said, a number of Fortune 500 companies as well as late-stage startups. With that, I would like to now hand it over to Fernando, who's going to give a brief introduction on what we plan to cover.
Awesome. Thanks, Sid, for that quick overview of everything that Witekio does and everything that Adrian and I kind of help Witekio do too. So for a quick introduction of what we'll be doing today, we're going to get started with this introduction right here that we already did, and then we're going to hop through a little bit of information about cloud platforms and connected devices generally, so you have an idea of some of the concepts that you'll need to know for really building any of your IoT embedded devices. From there, we'll look at some sample IoT architectures, so just a few examples of how you can use embedded devices with the cloud and some of the different pieces of those sorts of applications and architectures. Then we'll look at our first demo. So we'll show you the cloud side of IoT. We have a few different pieces that we'll show you. One will be more of a live demo. Another is just another example of some of the work that we've done to give you a little bit of a breadth of the sorts of projects that you can build with IoT devices and using the cloud. And then we'll talk really briefly about cost optimization and when you're working with the cloud, how you can optimize costs, because depending on the projects that you're working on, you could have lots and lots of IoT devices. And those devices might require you to really think about the amount of data you're generating, where you're putting it, and kind of making sure that you're not spending too much on those sorts of applications. And then towards the end, we'll look at how we can leverage the cloud for IoT, and just really give you a kind of complete picture of the rest of the materials there. So let's dive into it. We already did our introduction a little bit, but let's take one more moment to think about what the big deal is about cloud and about IoT. For some context, right now there's 35 billion connected devices by some estimates today, and customers are demanding more and more devices, and there are many, many more devices that are constantly getting added to that number. Um, there's also a process right now where a lot of these devices use something called CA root certificates, which establish trust between devices and different devices, and also between the cloud and other situations like that. And those CA certificates are sometimes going to expire at particular intervals, because you eventually need to renew them to make sure that, if they get breached or leaked or anything else, that you're not hanging on to them for too long while they're insecure. So because of that, that means that there's actually need to have those devices have some sort of rotation for those certificates. And that is kind of a big driver in what a lot of cloud connectivity sometimes comes down to, with that security rotation. And there's lots of different IoT solutions that you're going to be able to build out with these devices. So really, that's the context where we're kind of laying here for where the cloud comes from. There's also some other possibilities that the cloud enables. So not only the remotely updating and patching of devices, but things like predictive maintenance and alerting with the data that you're getting from the devices, and how you can automate and optimize your data storage when you're working with them. And finally, things like business intelligence reporting, where you're getting a bunch of information coming from devices in the field. You want to be able to look at that, sort through it, and figure out what that's actually telling you about whatever the kind of business purposes are for your devices. All right. So with that context out of the way, let's jump into looking at particular cloud platforms and how we can use them with our connected devices. So we're really focused in this talk on AWS and Azure, but you might be asking, why are we picking these two clouds and why not anything else? Well, these happen to be the two top public clouds for the last few years. AWS and Azure consistently rank in the top two in several different kind of developer surveys and overviews of the cloud industry, both in 2018 and 2019. And in 2020, there have been several different reviews of this sort of information. But in addition to these two public clouds, you might be thinking like, well, what else do we have? And Adrian, why don't you kind of guide us through some of those other options that we can look at?
Right. So one that we also use is what's available to you. There's for sure Google Cloud, so GCP, and all their IoT ecosystem. There are a lot of tools. They're a bit less used than AWS and Azure, but they have great solution, and sometimes actually can be more interesting in terms of pricing and some of their feature. We have IoT Connect, which is a way to simplify all your IoT pipeline done by Avnet. We have Alibaba Cloud, which is yet another solution for that. And Sixbond, which is like a dashboard to connect and have a global view of all your devices and what's happening.
Yeah.
So yeah, just some options. There are more, but we'll just focus on that. And the first two, I think.
And I think it's, it's important to say, especially that, Adrian and other people at Witekio have worked on, kind of a lot of these different platforms. We've put together open source solutions with things like Thingsboard, and definitely worked with a lot of these other tools as well. But it's good to keep these in mind, because you never know what needs you're going to have with the projects that you have. So diving into specifically why AWS and Azure, that's just kind of a high level overview. But let's look at kind of more when you're building applications, what else do we have to do here and why is this important? Well, we have IoT platforms in both of these clouds. In AWS, it's AWS IoT. In Azure, it's kind of expectedly Azure IoT. And in addition to these high overarching platforms that let us connect our devices, let us secure our devices, and do a lot of other interesting things there. There's also critically kind of the integrations that come into play to work with these platforms. So with both AWS and Azure, there's something called either Lambda functions or Azure functions, and these usually come into play working with how are you going to process the data that comes in through the IoT platform from your devices, and what are you going to do with it? Are you going to send it off to a database? Are you going to do some kind of additional sorting or collecting or aggregating of it? How are you going to treat that data? And then from there, where are you going to store it? Are you going to put it in something like a DynamoDB in AWS or a Cosmos DB in Azure? Do you eventually put it in kind of a colder storage place, blob storage in Amazon S3 or Azure Blob Storage? You have to think about those considerations after. And once you've collected the data, how are you going to visualize it? Are you going to use something like Power BI? Are you going to use something like Amazon QuickSight? How are you going to get the insights and actually look at them and know what's happening and share that with the rest of your team? In order to do that, you might also need to stream a lot of data through these platforms in a way that's a little bit more efficient, especially when you're going with kind of much higher volumes of data. And both AWS and Azure have streaming platforms that'll help you do that and process the data at that sort of scale. So now we have a good context of why we're talking about AWS and Azure. This isn't to say that other platforms don't have these tools, but just that these platforms definitely do, and that's one reason we're focusing on them. So the next step is thinking about when we have our devices, how are we going to get these to authenticate to the cloud? Now, when I'm talking about authentication, I mean, how are we going to say that the device is who they say they are? When I'm authenticating myself to Adrian, I have to prove that I am Fernando. But that's different from authorization, which we'll talk about in a second, which means that rather than proving I'm Fernando, I have to prove that I have the ability to use Adrian's credit card, which I don't, so my authorization would get rejected. So starting with authentication, we have something called symmetric keys, which are right now natively supported by Microsoft Azure, but they're really more focused on can you use these for testing purposes, because in production, we're usually not recommending these sorts of things because they sometimes lead to bad development practices where you'll get keys embedded in software, maybe reused, practices that you really don't necessarily want to have when you're working in a production environment. But there are a lot of other mechanisms that we can use. There's X.509 certificates that we can hook up our devices to. And we can also not only use standalone X.509 certificates, but we can use something called PKI chains of X.509 certificates, where we trust certificates down this chain. And we'll show a visualization of this in a little bit. But I think we have some other mechanisms that Adrian could cover as well. So Adrian, why don't you talk a little bit about that? Maybe I jumped the gun there. Happy to cover either one of these if you need me to.
Yeah. So there's Azure Sphere and their device claiming. Azure Sphere is really special. So for you, those of you who don't know, that's the name of the OS that Microsoft developed, which is really meant for to create secure IoT device. It's pretty young still, but for example, this specific OS, the way it works is really you're going to claim that device. So rather than having to manage the identity of the device and all the complexity and the security behind that yourself, you're just really going to claim that device, link it to a tenant in a cloud, and that's it. And it's going to handle all the rolling of certificates, all the underlying authentication of your device. So that's one example on one end, definitely specific to Azure Sphere. And there are other ways, like you can have a TPM or secure element. These will come with their own unique key, and you can use them to register that in a cloud. And there's even, if you have a very, if you want to produce a lot of device, you can use secure elements or TPM that come pre-provisioned with keys that are pre-authorized in your cloud, which is a very good way to basically have the easiest, most streamlined pipeline to authenticate your device, because you're just going to put a chip, it's going to connect to the cloud and be authorized directly with your TPM.
And so
just
for
to
those,
complete what Fernando said, the last option, that X.509 certificate chain that we're going to see, is most of the time the way to go. It's secure, it has a lot of value, it's easy to use. So yeah.
And for most of those people, or for some of those people out there who aren't as familiar with TPMs, definitely, coming from that cloud background, those are, Adrian's going to correct me here. I'm coming from the cloud background. He's coming from the, embedded background. So TPMs are that piece of the device that you're putting on there that deals with all the cryptographic operations and is that kind of secure piece of the device that does all those things for you, manages the keys kind of inside of it to make sure that, if somebody has access to your, I don't know, your refrigerator that you're building, like, and they get in there and they take the pieces apart, like it's harder to get access to the right things that they want to try and fake all of the API calls that they might be trying to hack you with or something. Is that accurate? You can correct me there too, Adrian.
Yeah, exactly. You're essentially, so you have TPM secure elements, but it does, in the end, it's exactly that. You're essentially storing your identity, your certificate in a secure storage that's going to be completely separate from the rest of the system. And that will be very difficult for others to extract because it's on a secure hardware component.
Great. Awesome. Cool. So now that we've covered authentication, let's switch planes a little bit and talk about authorization. So again, authentication is me saying, hey, I'm Fernando, and having some way to prove to you that I'm Fernando. The next step is saying, okay, well, I'd like to use, Sid's credit card, Adrian's credit card. And they look at that and they're like, okay, this probably isn't allowed. I don't have permissions for that, unless maybe I have a signed note from Sid. So with the metaphor there's different authorization mechanisms in different clouds and different tools. With Azure, there's something called shared access policies, and you can also control the different actions you can take through IoT Hub. You can control what sorts of keys you're granting to applications to take different actions inside of IoT Hub. And Azure has a few pretty simple mechanisms to help you do that in these different scenarios. With AWS, there's a few kind of more options that sometimes come into play with their IoT solution. There's IoT core policies, which are these JSON documents that you'll usually use to say, okay, does this device have permissions to publish MQTT messages to this topic? Do they have permissions to receive MQTT messages from this topic? Or kind of the granular control that you might want over those. There's also AWS IAM, or Identity and Access Management policies, and roles that you can use and assign to these different things that you're creating in AWS. And those will control, can your devices, for example, publish information to a backend database? Can they send information to a Lambda function? Or can they send blob information, JSON files, or something else to Amazon S3 to store for longer term storage? And you can control those policies pretty granularly too. And they also have a few other things that happen in the background. There's something called STS tokens, where that's kind of a short-lived, expiring token that allows you to do some of these actions inside of AWS, and other authorization services that are kind of more focused on users and giving users access to particular things in your AWS infrastructure. So now that we covered both authorization and authentication, let's take a closer look at one particular kind of authentication that Adrian and I mentioned before. And this is the X.509 authentication option, where we're going to have a chain of certificates that's going to allow us to have a bit kind of more interesting and more secure branch of how we're securing our devices here. And it all starts with the highest level certificate here, where we create a root certificate that then itself creates signing certificates, and it's registered inside of the cloud. So we say we're going to create this, we're going to go do a few cryptographic operations to make sure that AWS or Azure trusts that we own this root certificate and that we're the ones who created it and we're authorized to use it. And then after we've presented it to AWS and registered it there, we create a signing certificate. And that's kind of either called the signing or intermediate certificate and sits in between. And it's used to create leaf or device certificates. Now, this is a simplified version of what we might do. Sometimes there'll be more intermediate certificates in between. Sometimes we might have a few other things going on. But this at a high level is how it works. And those device or leaf certificates actually authenticate the device and are what's stored on the device. So let's look at a visualization of this. We have a root certificate. It creates a signing certificate, or that intermediate certificate, and we register it inside of the AWS IoT Core. Now, during our manufacturing process, what we're going to do is take this signing certificate, and sometimes there might be more than one, depending on the complexity of our manufacturing process. But then we're going to go through and we're going to sign different certificates to each of these devices. So they have their own private key and certificate chain signed up through that root certificate. And every one of these devices will then have their own unique leaf or device identity certificate throughout. And these will then be trusted by AWS because they're signed up through that chain. Now, once they have those certificates, they kind of move on to the next step. So we've set up their identity, we've set up their initial details with that certificate they have, but now they need to provision in AWS and get kind of configuration details and other information. Now, with AWS, this means that we can either manually register devices, which is a little bit time consuming and usually just for your kind of testing environment, or we might do something called just-in-time provisioning, which with AWS is when we use a template to provision our devices and get all the information from there to set up their things like their device shadows, or also called device twins, where the state information is stored between the cloud and the device. And also something called just-in-time registration is another option, where we use a Lambda function to process an incoming MQTT topic. And then when it gets messages, hey, I'm a new device, I'd like to register, it'll take that information and set everything up in the background for us. Another way to do this is to use a provisioning via a trusted user, so a technician, somebody on site who can take, an iPad over, type in a serial number, and get everything set up that way. And they're already authenticated, so they're able to do that in our system and be trusted. And one of the last things is similar to what we talked about with the claiming process with things, but basically in this case, you'll have one certificate. It's a little bit less secure, but one certificate you're using for claiming and getting an initial unique device certificate. So we kind of skip that manufacturing process and say, okay, let's just use this one certificate to talk to the cloud to say, hey, I want a new unique device identity. And then you continually use that certificate in your manufacturing process. But it's not as, it's a little bit more risky, because then you have to replace that if it gets leaked or you're worried about it. You have to deal with that risk as well. Are there anything else you wanted to add to this section, Adrian? I think the
so among like all the different options that you explained, for sure, if you're gonna have a product and you want to commercialize it and like really move to the production phase, you don't want to have any manual phase in that process, which means that like anything like the first bullet points, and well, at least the first bullet point is off.
Yeah.
You won't be able to do that if you scale to like thousands of devices. That will be time consuming and error prone. But there are definitely other options. You can either just have your manufacturing process and what happens in the manufacturing able to connect to your cloud to directly authorize these unique devices in the cloud, or you can use something that's a bit safer because you don't need that connection, which is basically what you described: registering an intermediate certificate, authorizing an intermediate certificate and all the leaves certificates, which means that during the manufacturing, you'll just be generating leaf certificates for these devices, and your cloud will be pre-configured to authorize those. So there's no manual steps. There's no need to add each device, even automatically, because all devices signed with that will be already authorized. That's an efficient way to go to design your basically manufacturing process.
Yep, absolutely. So to continue on that line of thought, when you're doing that and all those devices already have those certificates, the step that they actually take right after that is, let's say, we have this device, it's actually, has its certificate chain, so it's technically signed by that green and red certificate as well. It presents itself to the cloud provider. It says, hey, I'm device, blah, blah, blah. Here's my certificate. It's been signed by the root certificate. So AWS trusts it because of that. And it says, okay, let me go. And in this case, we're talking about a just-in-time provisioning process where we use a template. It says, okay, let me go grab the template. Let me return some information related to that template based on what you've given me in the certificate. Then I'm going to create the identity for your device, the IoT thing, the shadow, which is the way you're syncing information between the cloud and the device, and a policy, which is the permissions that are applied to that device. And then we're saying, okay, well, now that device has all that information, it can start to work with the cloud. A slightly different option is doing very much the same process at the beginning. Then we publish a message to an MQTT topic, which is then picked up by a Lambda function in AWS, which is some arbitrary piece of Python, JavaScript, other kind of code. And that then creates all the pieces of the puzzle that we want to work with. And then IoT Core says, okay, cool, we've created these. Now you're good to go. You can interact with the cloud. So that's how that kind of like last piece comes together, so that we can get the device and the cloud talking to each other and they know who each other are. Now, the same.
This is going to be,
Go ahead.
this is going to be a more flexible way of doing things. Basically, letting you have that Lambda, you can put, like, you can configure your device shadow, your policies and everything automatically, not based on a single template, but based on much more than that. So it's much more flexible if you want to do a more complex provisioning in the cloud for your devices.
Absolutely. And there's definitely options like that as well inside of Azure. The way that this works is, again, you have that option that we're going to throw out for production environments, which is that manual registration. But you can also use the Azure Device Provisioning Service, or DPS. And this allows you to set up enrollment lists of devices to be registered. Now, these can be, particular devices, or it can be entire groups of devices based on things like the intermediate certificates or the root certificates. And from there, that'll allow you to pick where they're going to get kind of thrown over to in terms of the Azure IoT resources, which are called Azure IoT hubs. So you could set them geographically, you could set them based on kind of like round robin back and forth. There's a few different options there. And some of the benefits of this is that you can do load balancing between those IoT hubs, meaning that you don't have everything going to the same one. Maybe you want to do some multi-tenancy provisioning so that you have customers in one region, or just a single customer you want to go to one IoT hub, a single customer you want to go to another. You can do interesting things like that. Or latency, what I was talking about with maybe geography, you want to move back and forth depending on what's going to serve the client the best. And you can also do things like key rotation with DPS, where it'll allow you to configure multiple different kinds of authentication there. And when you need to do rotation, either keys or certificates, it'll really help you to handle that process. You'll still have to do some work, but it'll definitely be useful there.
Yeah, and it's a good point, because like we're talking provisioning, so initial device provisioning, when your device is first going to connect to the cloud, you want it to be authenticated and to work without having to manually do anything. And this addresses that. But beyond that, you will want to roll your certificate and basically manage the security over time. And this is also definitely something that you have to have in mind, because it's not going to be just fixed at the time of the manufacturing. You can have like a 100-year long certificate, and that's probably fine. But you expose yourself to more risk. Usually it's good to keep at least that open, to be able to roll new certificate to your device, to update that from, like, for example, every year at least, so that even if you have a breach, even if there's a problem, you can always just basically save those devices.
Exactly. Yeah, that makes a lot of sense. And the process for that, that connection looks pretty similar to what it did with AWS when you're using DPS. There's a few differences, a little bit more back and forth, but you start with your DPS resource that you create in Azure, and then you create these enrollments that I mentioned. So here's a group enrollment where we say, okay, let's trust that root certificate, just to make sure we're on the same page about it. But we might also have individual enrollments where we might have symmetric keys or X.509 certificates or TPMs that we set up, that we allow either particular devices or particular sets of connections to go in there. Now, with either of these, then we're also going to need an IoT hub with Azure, so that our device can actually connect to something, it can store its device state, and do all of that. But when our device comes in here, it says, okay, hey, let's go talk to the individual enrollment. The individual enrollment says, okay, well, yeah, I know you're going to need to go over to this IoT hub, so let me create that information. Goes back and forth, brings the information back over to the device and says, okay, cool, you're over here, go talk to that. So a little bit of back and forth here with these arrows, but it's actually a pretty straightforward and quick process. And there's also that shadow in Azure, that's where all your details are getting configured and shared between the device and the cloud. Same thing, the device twins, sorry, yes. The terms differ between AWS and Azure, so I'm interchanging them a little bit.
Only different for every cloud, yes.
Yes. And so the same thing happens with the enrollment groups. You might just have multiple devices taking this process, where our device says, hey, enrollment group, hey, DPS, here's my scope ID for my Azure DPS, here's my certificate, tell me what I'm supposed to do. And DPS says, okay, I looked at this, it looks like you're supposed to go over here, let me create those details for you, I'll get them for you, let's go send them back over to that IoT hub. Now you know where to go, let's sync your information back and forth between IoT hub and the device. Now, we could actually do the exact same process with more than one IoT hub, like I mentioned, where we connect it not just to the first IoT hub, but maybe between multiple ones. So now that we know how we're authorizing, how we're authenticating, how we're getting these devices connected to the cloud for the first time, and what those secure processes look like, let's jump over and look at some sample architectures and things we might want to build with our newfound IoT knowledge. So the first thing we'll look at are some AWS architectures, and this is just kind of a quick example. With everything on the left, we have all of our IoT devices. Maybe we have thermostats, light bulbs, our water meters, everything that we're doing there. And with all those IoT devices, they're always going to loop in and connect to AWS IoT Core. And with everything we've just shown you, you've kind of seen how to connect them and how they get those initial states, but they're always going to work with that central piece and that central service. You might also do things like hook up analytics to them, output data to things like Amazon QuickSight, or then start interacting between the IoT core services with things like MQTT topics, interacting between that shadow that's storing the information about the device, or potentially setting up something called rules, which when you send information to particular things in IoT core, you could have a rule activate and say, hey, we want to take this information, and then we want to send it to a bunch of other services that we might want to integrate with. So do we want to send and store this data in Elasticsearch, or move it over into Kinesis to be processed in a streaming way? Or we might store it in things like DynamoDB, Amazon S3, Redshift, a bunch of other good, juicy database services or data-related services that we can interact with, or even process it in other ways. These are just a few examples. And there's also comparable Azure architectures where you're looking at a lot of the same really pieces of the puzzle and the architecture here in this diagram, where we have maybe a slightly different way of provisioning with that DPS setup that I mentioned, but we're still doing all of the same sorts of things where we're trying to visualize things, we're trying to do stream processing, we're trying to store information in a warm path or a cold path data store, maybe transformations with something like Azure Functions. And both AWS and Azure might have ways for us to do machine learning in the background on that data and kind of giving insights on the data and maybe taking particular actions from it.
Yeah.
Are there any other pieces of this, Adrian?
I'm sorry, yes. So there's a central concept as well that was present on a previous architecture and this one, which is that idea of device shadow, device twin, depending on how you call it. And it's always the same concept. The idea is really you want to have, and this tool provider provide that, a copy of the state of your device in the cloud. And the reason for that is if you want to, for example, filter on the device, if you want to, for example, upgrade device on you that have a specific version of the software, if you want to query some information or set some configuration, these device shadow or twin are really the representation of your physical device, but accessible at all time in the cloud, because the connectivity is what it is, or maybe your device is not always connected. And that's really the purpose of that device shadow, to allow you to query this information, as well as to set some configuration that will be available to your device later on when it comes online. So that's really usually a central piece of any IoT cloud architecture, along with like tools like IoT Hub for the communication and DPS or other for the provisioning part of things. And then of course you have all the cold store, warm store, and AI, etc. But that device twin concept is definitely central.
Yep, absolutely. Definitely. And that device twin concept and a lot of these other concepts, once you get familiar with what those are, you're going to see those pop up in even other clouds or other tools that you might be working with. So there's definitely the ability to use very similar concepts and services in other clouds as well that have support for IoT use cases, just because they have to have the same building blocks in order to really do anything with IoT devices.
Right.
So I'll skip over the GCP. This is your little bonus slide. And let's dive into the next step, which is for us to take a look at some of the demos that we have here. Now, the first one that we'll be looking at is related to a chocolate security system that I put together here on my desk. It's also kind of my lunch security system to keep an eye on my lunch in case my dog is, jumping up on my chair and trying to get access to everything. It's actually why I sit on a ball now, which is, in case you see me bouncing, is why I'm bouncing. So there's a
Yeah.
few different pieces pieces of this. There's obviously the chocolate, but let's take a look at just kind of the pieces of the hardware as well. We have our standard PIR sensor, which is a passive infrared sensor. And we also have the Raspberry Pi device that I'm using to connect to it, and the cables that I'm plugging into everything. And I've already set this up with Wi-Fi, everything else. I've actually done some manufacturing processes that we'll talk about in a moment. But we obviously also have my chocolate here. So let's take a look at the architecture of how we're going to put together a security system to be notified whenever something moves in front of the sensor. Well, here's the quick cloud architecture, the quick and dirty version. We have our front end, which is our customer web portal. Anybody who signs in will be able to tell whether or not my dog is stealing my chocolate recently. And actually, you could technically do this too if you wanted to. So in my web portal, I am using something called Vercel to deploy out all the front end code that I have. And I've also created an Amazon Cognito resource in AWS to allow me to sign in and to be authenticated in that application, and to make API calls that are authenticated and authorized because I've signed in as a signed in user. Then the next step for me is to set up Lambda functions that will talk to backend resources. In this case, I could set up something to talk to resources like Amazon DynamoDB. I could also set it up to interact with AWS IoT Core and the device shadows that Adrian was just talking about in more detail. In fact, that's actually what I have done in the code in the background here. Now, the last step is I want to be notified about it. So I want to hook into kind of the power of the cloud. And every time I see, this being triggered on the MQTT topic from the device where I'm waving my hand in front of the sensor and it's notifying that, I want to know right away and get a text message. And for that, I'll use a service called Amazon Simple Notification Service, or SNS. So the last piece is all this kind of shadow information that I mentioned, where the device will be talking to IoT Core. It'll be syncing information back and forth between its shadow. And whenever that happens, I'll get notifications, or I'll have the ability to process that kind of back and forth data. So now that we know what this looks like, let's take a quick look at the code before we dive into the actual code that I have here, and try testing this out. My device is on, so we're good to go in a second. The highest level portion is the front end. This will be the first thing we really briefly take a look at. It was just a very simple one that's set up with Vercel to deploy in my GitHub repository. Whenever I push to my GitHub repository, it'll change things in that front end. And it's set up with Cognito URLs I need to go get my sign in, sign back in, redirect me. It'll send me some credentials in the URL. That's all processed by the front end, and it works pretty smoothly. The next step, kind of chronologically in our process when we're thinking about manufacturing, is this manufacturing section I have here. Now, inside of this, I've done a few different things. I've gone through and written some bash scripts for us to create and register certificates and certificate chains inside of AWS. I'm not going to dive into these too much during this call, during this webinar, because it's probably a little more involved than you want it to be. But if you have questions about this, you're welcome to reach out to us later. And once we're done with this process, this is really more of a manual one that I've done personally with my device, but it'll look a little bit different in a production scenario. Now, assuming that we've created our certificates, we've kind of set everything up on our device, the next step is for us to send messages through the MQTT topics to AWS, and that's what the connection attempt script does on this device, and I'll show you that. So now that we've kind of covered the high level, let's go over to my code here. And you'll see the actual thing of what I'm doing. So let's call this dog. Let's leave this as dog monitoring system. I'll just add, actually, let's just call this lunch monitoring system for right now. So right now, if I load up my website, it's currently called dog monitoring system, both my title and my little piece right here. So let's change that. I want to make sure that it's set up to monitor my lunch, and this will show you how Vercel is kind of integrated nicely. I'm going to prove to you that I'm not cheating by just refreshing this page and showing you that it's there. And then let's do a quick get status. Let's add this change that I just made. Let's commit it. It's a little harder to see my command line here, so let's open that up. New title. Now we're good there. So let's push this to my GitHub repository. Oh no, looks like I need to fix that in a second. So I'll do that in 1 minute, and we'll push it out after I've done the rest of the test. I'll show you that in a second. But the next step, once we've kind of pushed these updates, as I open up my password manager in the other screen, is to actually go over to the device. Now, what I've done is on my local network, I have my camera and move myself over here. I have my Raspberry Pi set up. If you can see the screen, the red light's on. It's good to go with my PRS sensor. It's all set up. It's connected to my Wi-Fi network. And in order to get it to run, it's kind of set up to monitor everything. I've SSH'd into this device, and if I list the contents here, it's already got everything it needs. It's got its certificates. It's got a script in Bash that I'll use an MQTT topic library or MQTT library to send messages to AWS IoT Core, and it's got a little Python script just to help me kind of manage that at a higher level. So in order to do this, let's go ahead and do Python 3 run.py. Okay, nothing's happening yet. So let me, before I wave my hand in front of it, let's see if I can show this live as I get the text messages. Oh no, does it show up on my screen, or am I in? Oh yeah, it does. Perfect. Right there. We just got our text message from our notification system. So let's open that up.
Yeah. It was brief, but yeah, we saw it.
And then we got it right there. We have our notification saying, hey, your dog is trying to grab your lunch. So the way that this is happening, let's close this out really quick so I don't get too many more text messages. The way that this is happening is it's going from the PIR sensor to the device. The device is sending MQTT messages into AWS IoT Core, and then we have an entire backend application that's actually processing these messages. So whenever a message comes into the AWS IoT Core setup, I actually have a particular topic called alarms that I'm monitoring, and as soon as that comes in, it triggers a AWS Lambda function, which is right here. And all this essentially does is it sends me a text message using the Python extension. I don't want to look at you right now. Using the SNS publish method of a SDK for AWS. And then it sends me a text message. There's my number, so I guess you can text me your questions after. And that's the majority of the process here. We can add a bunch of other details that'll help us kind of figure out all those pieces. But the next step really is to go over to our front end, right? And we wanted to make this available to anybody. So technically, if you went to this website right now and you signed up for my dog monitoring system, you can see the last time, if you log in and you sign into your account, you can see the last time that my dog has gone here and moved in front of my sensor. So I give that gift to all of you as well. So this is kind of a sillier example, right? But let me go back over to the presentation to show you what can happen in more of a production environment. So right here, I have.
We can also note that everything that you've done, of course, this is an example. Well, like maybe that's the way you do things in 2020. I guess previously you just use a drawer and maybe a lock or your fridge.
Yeah, exactly. Yeah, well, you don't know how often my dog will try and eat my food, so you don't know the levels of my desperation, Adrian.
Yeah, maybe even locksmiths.
Exactly.
Yes.
So in a more kind of real world environment, a more real world example, let's look at what some of the other possibilities of cloud are. Well, we've worked with clients in lots of different industries who want to create and connect industrial and other equipment to enable new possibilities. And in this particular case, we have a crane manufacturer who wanted to develop a way to remotely operate a crane. And so in the demonstration you're seeing, there's 3 different components to control our crane with, in this case, a slightly smaller demo connected crane. So we have the crane itself with all the motors and the various operational pieces of the crane. And we have a cockpit application that you're seeing, which allows an operator to control the crane remotely using this cockpit interface that shows you all the details. And finally, there's also this cloud portal, which will summarize, as a prototype, relevant information about the conditions that the device is operating under. So this is something like the current load, the speed, the motion of the crane, the wind speed, rotation, a bunch of other kind of metadata that you really need to know if you're operating an actual crane. Now, obviously, there's lots more information we could we could add to these sorts of portals and platforms to make sure that crane operators have their full display of sensors and information. But with these components, you can really do a lot more, like set up alerts or safeguards on the operation of devices. For example, maybe there's higher wind speed than the crane is supposed to operate in, or maybe super heavy loads that you need to trigger notifications to tell some sort of overseer, hey, this is either too much, or hey, maybe this triggers some elevated security level or kind of risk assessment on the site that the crane's operating under. And that's, let's go ahead and scooch over to the next part. And that's really just one of many different opportunities that Witekio has been involved with to build actual devices. Adrian, why don't you cover some of these and just give us a quick high level?
Oh, sure. Yeah. So, well, yes, that ranges from coffee machine. Yeah, we're doing a lot of coffee machine these days. It's always nice to have, right? But ranges from consumer devices like this to medical devices to, that could be a truck or even military vehicles or industrial machines. And for all of these, I mean, nowadays you always have some connectivity into that. So that's really where that's what we love to do. And that's where we usually help design a whole manufacturing process, how to secure it, work on the hardware support and the connectivity and how to put all the pieces together. So there are probably too many to name, but some examples, some pictures of what project we're working on.
Definitely. Great. Well, let's take now that we've kind of imagined this full solution and we've got all the pieces of it kind of on putting it together initially, the next step is to think about how we can optimize some of the portions that we're talking about today, which are the cloud portions. So I'm going to give you a few tips really just as kind of your parting gifts for when you're doing this to make sure that you're getting the most out of these platforms while paying the least. So let's look at Azure and AWS to start and just think about their core kind of product that we're working with, which is Azure IoT and AWS IoT. Now with Azure, there's a few kind of critical things you need to do right when you're starting with IoT and IoT hubs. The first is to select the tier that you need when you're creating IoT hubs. There's basic and standard tier, and you need to understand if you need bi-directional communication or not. So if your devices are just sending information into the cloud and you don't need the cloud to talk back to the devices, you can set up a much, much cheaper option in Azure IoT. And it also allows you to kind of save a bit of money there. Now, you can also tune the number and the type of IoT hub units that you have, or set up auto scaling for IoT hub to make sure that rather than having 20 more units than you need or 20 more hubs than you need, it only goes up as you actually add a bunch of devices to your fleets. And you can also tune your devices and applications themselves to reduce the usage that they have of the IoT hub platforms and kind of save yourself some money that way. With AWS IoT Core, it's right now currently pay per request pricing and feature pricing for a lot of these. So what that means is that you might want to reduce the usage that you're having from these platforms to only what you're actually requiring, and make sure that you're reducing the connectivity, things like messages that you're sending, or bundling data a little bit more effectively to try and get the most bang for the amount of money that you're spending on it. You can also optimize the message sizes and what you're sending for metering. And a quick example of this is, let's say you have an 8 kilobyte message and 5 kilobyte metering, you're going to be charged at 10 kilobytes on that platform. So if there's ways that you can kind of keep your chunks right below what the metering thresholds are as you're sending messages, sometimes it'll help you to get a kind of optimized costs there as well. Now there's also a lot
absolutely.
Or go ahead. Yeah, go for it, Adrian, if you have.
No, I was going to say that's a good point because you usually like these costs, depending on the amount of data that you want to transfer, this can quickly add up and everything. There's I mean, you will have to send that data one way or another. It can be sent maybe zipped together or maybe through IoT Hub, depending on what you need in terms of latency and everything. But yeah, optimizing the size of your message for basically the rules, the way it's priced, is definitely something to consider early on in the design, because it will just be cheaper. You'll have more value for the same price if you do that. So it's a good point. Yeah, the communication, the cloud communication is something to study, the payloads, what you transfer when, etc.
Absolutely. And there's definitely a lot of pieces to that, not just for the IoT perspective, but for the data transfer in and out of cloud fees and lots of other pieces that you might not initially be aware of when you're working with those clouds until you see your bill from having communicated too much. So definitely reach out to us if you have questions about that. There's also general cost optimization strategies that are outside of kind of that IoT realm. One of the first things here is called right sizing, where you can take appropriate instance sizes if you're working with virtual machines, or appropriate capacity units if you're working with other services. And so you're not going overboard on what you're using. There's also different purchasing options that you can use. There's things like spot instances, which you can essentially buy on a marketplace of, hey, I'm not using this device. Both AWS and Azure have opportunities for you to say, okay, I'll rent that for 30% or 70% or some lower amount of what it actually normally costs just to rent it on demand. But if somebody else goes, hey, I want to go and rent this, you might have to give it up. So that's the downside of spot. But you can also use reserved instances, where if you have a fleet of devices that are definitely going to need compute capacity, you need your applications running on them, you tell AWS or Azure, hey, I'm going to commit to using these sorts of instances in this time frame. I'm going to say I'm on the hook for the bill. And AWS or Azure will sometimes say, all right, we'll give you a pretty steep discount as long as you're promising to use this. And that's that same thing for reserved capacity, where instead of virtual machines that you're reserving, you might reserve capacity in managed services or other pieces of the cloud infrastructure. Now, another one is called utilization, where obviously if you're using different services, you want to make sure you're getting the most out of them if you're paying for them. You can do things like use managed services, which scale up and down whenever you're actually using them to make sure your utilization is very high. Or you could use things like auto scaling, load balancing, to make sure that you're sending requests to the right places and that you're only going up with your scaling when you need it and you have a bunch of requests coming in. And finally, there's some techniques in your architectures you can use, things like buffering, where you stream data into be processed kind of in batch, or maybe you buffer data into queues and process it all at once when you have available resources. And those pair pretty nicely with things like spot instances as well. So let's look at some specific examples that if you even have an application right now, maybe you can take home and start to look at. So with IoT hub tiers in Azure, the basic tier units, I mentioned basic and other kinds of tiers, these are $10 to $500 a month for the highest tier and the lowest tier. But there's also standard tier units, which are $25 to $2,500 a month. So essentially, if you pick the wrong kind of unit when you don't need bidirectional communication, you might be wasting 60 to 80% of your cost already. So this is a kind of, just initial really critical point to think about when you're picking what you're doing in the cloud. And there's also IoT core pricing in AWS that you can start to look at, where you can do pay per request and utilization of specific features, or make sure you're optimizing those applications to reduce the utilization like we mentioned. Now, there's another big area that I think some people miss when they're working with AWS and with Azure, which is to look about the storage classes that you can use in blob storage. In AWS, that's Amazon S3. And there's a standard storage class called standard storage, where you pay 0.023 cents per gigabyte. This is for a particular region. These prices might vary depending on as AWS changes them or what region you're in. But in that same region, you can use Glacier Deep Archive Storage for 0.00099 dollars per gigabyte. Excuse me, I think I said cents before. And you can actually automate the process of moving between the standard storage classes and these much cheaper storage classes. These are just two examples, but there's actually more in between them. So rather than having to individually move your one JSON file with a bunch of data that you never use, you can set up these automated policies to say, hey, in 60 days, move this thing into a cheaper storage class because I haven't used it and I'm probably not going to use it. And the same thing with bringing them back and forth between those classes. And the exact same thing exists in Azure, where there's premium, hot, cool, and archive storage types, and you can create lifecycle policies to migrate between those to save yourself a decent amount of money. Especially as your data volume grows, it's pretty critical to do that because that's where a substantial portion of your bill might come from, is from that storage. Great. So now that we've covered some of these tips, let's look at our last section here, which is to really think about how you can start leveraging the cloud for AWS, for Azure, in building your IoT devices. So Adrian, why don't you take it away with some of these options that we have here?
Yeah. So I mean, we've seen a lot of different things. But if we start with the first, so like the device provisioning, this is really going to be the first challenge or the first thing that you'll have to do when you set up your IoT architecture. So this is like either Azure DPS and the equivalent you have on AWS, how you manage your certificate, how you manage your manufacturing process to make sure that your device can authenticate and connect to the cloud in a secure way. Then you have OTA updates. So again, every OS and embedded OS have different ways of doing that. Like depends if you're an RTOS or if you're using a Linux embedded, you have open source solution that can help you with that. For FreeRTOS, you have also a you have actually AWS that can directly help you distribute these updates. So depending on the updates, you just on the OS, sorry, you want to pick the right architecture to structure your solution around that. You have the device monitoring, which is a really neat way to just understand what's happening on your whole fleet of devices. And this will, for example, directly use the device twins that we mentioned previously to kind of get some of this information across all these devices. And telemetry, of course. So again, that's like these data and packets that we mentioned, that you have to make sure that you have the right size to minimize the cost. But all these services have way to transmit data, to broadcast information, to send information specific channel, to subscribe and distribute those. So the telemetry will be the last piece to enable all the big data application and AI application of your device.
Absolutely. And for the second half of these sections here, we talked briefly about some of the processing of things like AWS Lambda, visualization tools that you can enable in these clouds. But there's a lot of different options there, and depending on what's right for different organizations, those are things that we have worked on, we can work on. We also talked about some of that data storage, lifecycle management of that data to make sure you're getting the best out of your costs there. But it also comes into where do you want to store that? How do you want access to it? Is it a data warehouse? Is it kind of cold storage because you don't need it? You really just want to keep it around to eventually add. A lot of different questions to ask there. And what Adrian was saying, with a lot of that telemetry information coming in from your devices, storing it everywhere, or storing it in your applications, from your applications, you can then develop potentially machine learning models that make use of that data and help you do predictive analysis on things that are happening in your environments, depending on how much data you have, and how useful it is to create those machine learning models to give you that predictive analysis. And of course, like we mentioned, web applications to enable you not only to let your friends see whether or not your dog has stolen your lunch, but also to really give access to industrial applications and other technicians that might want access to in the field devices, to save them from having to go out actually to those devices, because those can be costly trips if you have to send somebody over to that water meter, over to that crane, rather than allowing them to do that sort of work remotely. So a lot of different possibilities here, and if you have questions about it, definitely reach out to us. So if you're ready to get started, Sid, who is on the webinar right now, is definitely the person to reach out to. His email is here on the bottom right hand of the screen here. You're also welcome to reach out to me. I put my connection information here, and Adrian as well. I think both of us, if you want to reach out, just email us and we'll get you connected to the right person. And if you need kind of an initial look at what we might do, one of the first things we sometimes do is a cloud workshop where we evaluate your needs and the possibilities that we can help work with you. We can help you spec out your application, see what the different pieces of work that you might need are, and help you prototype the things that you really want to be involved with. And if you just want some guides on getting started for yourself, I put two here that are on the blog, the Witekio blog, that you can go and look at. These will take you through everything from where do you buy the hardware that I have sitting on my desk, what hardware do you need, how do you get it connected, how do you get into these platforms, how do you get all this stuff working, and it should give you a really good initial overview of how you could do all that. So with that, I think I just want to say thank you to everybody here, and we can answer some questions if there's anything in the chat there that we can dive into. I'll leave this slide up here so you can write down Sid's information, my information. Adrian, I think we should put your email somewhere if you want emails. Otherwise, we can protect your inbox, whatever you're interested in.
Sure, yes, can you? Thank you.
So I will look for questions. I'm going to leave this up, but let me read the chat. Let me try and read the chat, and then I will go from there. Looks like we have a few coming in. So are we going to share the information after the webinar? Yes, we can definitely share the slide deck after the webinar. If you want to make sure to get that, just reach out to me or anybody else, and I can definitely do that. And if anyone has questions right now, this is a perfect time to throw it in the chat, or you can also definitely reach out to us later if you want to talk more with Sid about the things that we offer, or other pieces like that. Perfect. And Adrian's email's in the chat too, so you can reach out to him as well.
Yeah.
Awesome. Thanks, Karthik. I appreciate it. Thank you, everybody who joined. It looks like a bunch of great people in the chat. And I don't hear too many questions now, but if you have them, I'll be here for a few more minutes just in case. I know we went a little bit close to time here. Awesome. Sid, anything else you want to share before we hop off?
No, I think this was very helpful, Fernando and Adrian. Thank you. Looks like the audience does have one question. Questions regarding moving from one cloud platform to another.
Yeah. So how much effort does it take to move from AWS to Microsoft Azure? That's a really good question. And like all really good questions, the answer is usually it depends. When we're talking about doing a migration from one cloud to another, it really comes down to what sorts of applications you have in the initial spot. So if you have, if you have all of your infrastructure already in one of those clouds and you have to move everything over, you have to think about what pieces can you do, effectively to start. Can you kind of start moving over safely, kind of independently of existing applications? Do you need to do things that are kind of moving critical infrastructure versus easy wins? Like, how do you divide those up? In terms of moving like an IoT application over, an infrastructure application over, that sort of decision is probably a little difficult. If you already have embedded devices in the field that are already programmed to communicate with one cloud, it might be possible to make those sorts of changes if you've got a good kind of remote update system in place already. But with that said, if you need to switch over to a new cloud, you definitely need to think about, okay, how do we change the underlying applications that exist on this device already to make sure it can move from the initial cloud to the second cloud? How do we migrate our certificates, our PKI infrastructure, public key infrastructure, over to this new cloud? How do we make sure that this new cloud has the trusts all these leaf device certificates, trusts the root certificate to sign the intermediates down through that chain? How do we verify that and validate all that? How can we test that to make sure if we move one device over that it works, and just make sure the rest will work too? Adrian, I don't know if you have other thoughts on that as well.
Yeah, for me, I guess that's a defeat. Once you define it for life for your device.
Yeah.
You can for sure change it, but it's going to have a lot of impact on. Yeah. Well, it's going to have an impact on your manufacturing process, on your device, how to transition the old ones to the new one. That would be a risky move. So usually, it's much safer to you can just, I guess, create a new project or roll out the next version. Yeah. But yes, yeah.
Yeah. I think it's definitely easier with more web related projects, but definitely the embedded side, you're tying it so closely to that cloud, it can be difficult to differentiate from. Looks like we have one other question here. Would it be possible to support a hybrid cloud environment, AWS and Azure? Say an AWS cloud-based company acquires an Azure cloud-based company and wants to form some connectivity between the two without having to port everything. So I think there's definitely, you can definitely do that. If you're thinking about web applications, you can definitely support multiple web applications in different clouds. We're thinking more on the embedded IoT side. It's exactly what Adrian was saying before. It's a pretty big commitment to shift that manufacturing process over between clouds. But that's not to say, for example, in my architecture slide earlier, that we couldn't move my front end or my back end code from one cloud to another potentially. The back end is a little more tied to the IoT infrastructure, so that's a little harder, but definitely the front end pieces can still communicate with the back end pieces if you want to migrate those sorts of pieces as well.
Yeah, that'd be just a matter of designing a whole thing. I think in that the question is more in the sense of just the cloud part.
Yeah.
And usually it's maybe not ideal in terms of maintenance, but you can definitely just have a hybrid cloud solution, maybe for cost reason or just legacy, or just you have two systems that you want to connect.
Yeah, definitely. And that, I think a lot of those hybrid cloud environments are usually just when you already had one application in one cloud, one application in another cloud. Same thing for when I hear people saying multi-cloud. Usually, when I hear people trying to force that down, they're thinking, "Oh, we're going to do the exact same thing in multiple clouds." But what it really comes down to in practice is probably like, "Oh, hey, we have one application here, one application there, and a third thing over in that managed services provider or something." So. Yeah, good question. All right. Well, I don't see too many other questions here. So thank you again to everybody who showed up and arrived, and thank you to everybody who asked some questions in the chat. Again, hopefully, we'll hear from some of you afterwards. Definitely feel free to reach out to us. And thank you for joining again, and thank you both to Adrian and Sid for taking us through a lot of this information here. Appreciate them joining. And we will hopefully talk to you all again soon in another webinar.
Yeah, thank you, everyone. Thank you, Fernando.
Have a good week, everyone. Bye.